I have always been curious about how knowledge is formed and concepts are born. More specifically about the practical procedures that push us as human beings to seek deeper levels of understanding. I think that understanding the practical necessities that have brought us to develop the conceptual ideas that we blindly use can help us to comprehend those ideas even better. I have always been passionate about teaching, and I think that there is something noble and mystical in being able to transmit knowledge. Given this fact, and given that I need to learn deeper about statistics in my career, this is going to be the first video on a series where I go and explore its theory and practical use. Before diving into the basic concepts in this first video, we will concentrate on the history and origin of statistics as a science. It is considered as the starting point of the study of probability, the correspondence between Pascal and Fermat, in the middle of the 17th century, discussing the problem of points, which we will explain later on this video. But the use of probability date way back in time. It is an empirical science, so it is difficult to trace, but generally there are considered two main reasons that have pushed us to have that as a science. First is our need to solve gambling problems, and second, our need to give sense to mortality data and insurance rate. Even though back in time there was no clear concept of randomness, people introduced it in games through cubic-shaped dice-like instruments that we now call astrogale. They were small marked cubical bones that people used in spiritual activities as divine consultation from the oracles, or also simply in games. Even though there was no clear understanding of the concept of randomness, people clearly felt the need to introduce it in certain activities. It might be the desire of humans to gain something for nothing that have pushed the game of chance into existence. In any case, evidence of them have been found as far back as 3500 BC in Egypt. For example, Senet. It was a game that was played in 30 squares arranged in 3 rows of 10. The game reflected the concept of life force passing through the afterlife, and its original rules were lost when the Romans came. Moving forward in time in Rome and Greece, the games were gaining very much popularity, as much as at some point they had to ban them legally to protect the people from gambling too much. Moving forward to the Middle Ages, we find the Catholic Church that builds campaigns against the game of chance, more because of the drinking and swearing that accompanied them than because of the games themselves. During the Third Crusades, knights were allowed to gamble as long as they didn't lose more than 25,000 shillings a day. During these long centuries of gambling, there was not observed any link to mathematics. It could be because the concept of randomness was against the philosophy of the time. Maybe for that reason, there was no systematic investigation of the concept of randomness until the Renaissance. The first mathematical treatment of probability began in the 1500s with Girolamo Cardano, Italian mathematician. He was a professor of mathematics and medicine and a much big gambler. He passed a period of 40 years gambling each day, and since he did not want to lose time and money, he seriously began to analyze the probability of his winning. And of course, he reported those results and wrote a book about it to help his fellow gamblers called the Book on Games of Chance. And in that book, for the first time, we have seen the concept of honest dice. Before Cardano, chance was widely seen as a matter of fate, magic, or divine intervention. By introducing the concept of an honest die, Cardano shifted the framework from superstition to science. This way, there was introduced the concept that an honest die is one that follows the mathematical laws of chance. While Girolamo Cardano was one of the first to analyze probability systematically in his work Liber de Ludo Alea, the book on games of chance, historians largely agree that the scientific study of mathematical probability was truly ignited by the problem of points. The problem of points concerns how to fairly divide the stakes of a game between two players if the game is interrupted prematurely before a winner can be declared. Scenario: 2 players, assumed to be equally skilled, are playing a game where the first player to achieve a set number of points, say n, wins the entire stake. The game stops when player A needs A more points to win, and player B needs B more points to win. the question: how should the total prize money be divided based on the current score, A and B, rather than just splitting it equally? The challenge lies in determining the division proportionate to each player's probability of winning if the game had continued to its conclusion. This problem was first formally presented by the Italian mathematician Luca Pacioli in his Summa de Arithmetica, in his 1494 book Summa de Arithmetica, Geometria, Proporzioni et Proporzionalità. Several prominent scholars attempted to solve it over the next century, but failed to find a mathematically sound solution because they focused only on the number of already won games, not the number of potential games remaining. The problem gained renewed attention in the 17th century when it was brought to the attention of French scholars by the writer and amateur mathematician Chevalier de Méret. Lacking the mathematical tools to solve it, de Méret presented the problem to Blaise Pascal. Pascal, a famous French mathematician, initiated a correspondence on the subject with his colleague Pierre de Fermat, starting in 1654. Through their exchange of letters, Pascal and Fermat developed the fundamental concepts required for a definitive solution, specifically the use of combinatorics, counting all possible outcomes of the remaining games, and expected value. This correspondence laid the definitive foundations of mathematical probability theory, and it is considered as one of the great moments of mathematics. And this is the first part of the origin of probability and statistics. The second part will concern more specifically how the mortality bill influenced the birth of statistics as a science.